Section 9.4 is parametric equations. What we will look at with this section is we'll talk about evaluating sets of parametric equations for given values of the parameter. We'll graph curves that are represented by sets of parametric equations. We'll rewrite parametric equations as a single rectangular equation by eliminating the parameter, and then we'll find sets of parametric equations for graphs. So we probably first need to kind of talk about what a parametric equation is. And so up to this point, you've been representing graphs by a single equation involving two variables with x and y. So normally we would have like a y equals x equation. And these equations that we've been using are called rectangular. So rectangular equations are the equations that just have the x and the y. But in this section, we're going to throw a third variable in there and actually split up the x and split up the y. And so the reason that we do that is so we can look at graphs separately in terms of horizontal and vertical, and they're not tied together anymore. So if we look at this equation here where it's like a projectile, and they give you the initial velocity is 48 feet per second, and then the object follows this parabolic path. So if we were just graphing it regular, this would be your rectangular equation. And so if you were given a time x, you could find a height y. But what happens is if we use parametric equations, we can actually separate by throwing a t in here, where t is represented with time. We can find our horizontal coordinate separate from our vertical coordinate. So the idea and why we would do that is because with rectangular equations, you don't always get to see the full picture. You don't necessarily know when the object is at a given point, but you might know where it was. But the parametric allows you, I guess, to figure more things out about your equation. And so that's where that t is introduced, which is called your parameter. It's like a limit on where you're allowed to be for this equation. So what happens is we have this set of equations. Sorry, I'll go back. So your parametric equations would look like this, where you have an x equals equation and a y equals equation. And these are two kind of separate equations now, and each one will have a t in it, where t becomes that parameter for the x and for the y. And so from the set of equations, we can determine when time is 0 that the object is at the point 0, 0. Or when time equals 1, we can figure out the horizontal and vertical placement of the object as well. So for motion problems with x, where x and y are continuous functions of t, you still end up with that same parabolic motion. So here's your definition of your plane curve. If f and g are continuous functions of t, so these two parametric equations are continuous, then the point f of t and g of t represent that x coordinate and the y coordinate. So if you plug a t value into your x equation, that would give you an x coordinate. And if you plug a t value into your y equation, that would give you your y coordinate. And so one way to sketch a curve represented by parametric equations is just to plot the points once you're given the equation. Plotting the points results in the order of increasing values of t. And so the direction of a parametric equation actually is specific, and it's called the orientation of the curve. So if we look at this first example, we need to sketch the curve given by the parametric equations. So our equations are x equals t squared minus 4 and y equals t over 2. And t has to be between negative 2 and 3. So when we're looking to plot points, what we're going to do, and we already set this up in a table for you so we don't have to write it all down, is that in our table, you have three components of your table. We have our t values, and because t is from negative 2 to 3, I'm going to list the t as negative 2. I'm just going to use whole numbers, negative 1. They're not whole integers. 0, 1, 2, and 3. And then the way that we come up with our x coordinate is you're plugging the t value into the t in your x equation. So when t is negative 2, to find our x coordinate, we would say negative 2 squared minus 4, and we would get 0, which is where that 0 came from. And then we could plug a -1 in and we get -3. And so then to find your y coordinate, you do the same thing. So if t is -2, we would say y is -2 over 2. Again, we're plugging that -2 into that t value in the equation, and that's where that -1 comes. And then we could go through that with all the points. And so then the next step is these x and y coordinates here are really just points on your graph. So if we were graphing these points, this would graph as the point 0, -1, since x is 0, y is -1. And then the point -3, -1/2. And then we could graph the point -4, 0, right? And we could go so on. So the x and y still stay the same as points. And so when you plot the points, this is what happens. Right? So we plot these points and we find out that this is our first point right here that we plotted. So that's where we're starting, and then we go through and we plot the rest of these points. And then this right here would be the last point. And so this orientation, these arrows right here show you the direction that this graph is being drawn. So what we know then is when the particle moves, it would start at the point 0, -1, and it would move along the curve, and it would end at the point 5, 3/2. So now let's say we wanted to use our calculators to graph in parametric mode. So what we need to do in our calculators is actually go to your mode button. So get your calculators out, hit pause if you don't have your calculator, go get your calculator out. And once you have your calculator, go to mode and choose par. So if you go to your mode and go down to the fourth option, right now it's probably function, and you need to go over to the par, right, and hit enter. And then if you go into your y equals, you'll notice that in your y equals in your calculator, your y equals, you'll have an x1 of t equals, and then you'll have a y sub 1 of t equals. So that's like your parametric equation, your x equals and y equals. So when we look at part A here, if we were writing this, we would say, okay, x is t and y is the square root of t. So in your calculator, where your x sub 1 of t, you're going to hit t. Now your t button, to find your t value, you're going to use the button that's the x, comma, t, comma, theta, comma, n. Right, so if you hit that button right there, when you're in parametric mode, a t shows up. And then in your y equation, do the square root of t. Okay. So then what we're going to do is then you have to go to your window. And if we go to our window, our t is the value that we want to start with. So if we're looking at these two equations, we know that t can't be negative. So let's start t at 0, and let's just graph up to where t is 10. So our t min will be 0, and our t max right now we'll just set as 10. And then you have to set, and your t step will do 1. So that's how often do we want it to graph. So they'll plug like a 1 in for t, a 2 in for t, a 3 in for t, right? And so then your x min and max, so if t is going from 0 to 10, your x should probably also go from 0 to 10. And then your y should probably go from 0 to, it could go to 10, but we know that the square root of 10 is 3. So maybe we go 0 to 5 for y, right? And then hit graph. And you'll see when you graph it that you get a graph that looks like this. And so if we were to do the vertical line test, we would see that that does pass the vertical line test. And so we know that part A is a function, right? So in B, we're doing the same thing. Go back into your y equals, but this time you're going to graph t squared in your y, in your x1, and t cubed in your x2. And so now for our window, let's go let's go -5 to 5 for t. For x, let's go -25 to 25. And for y, let's go -150 to 150. And so when you hit graph for that one, what happens is we get a graph that kind of looks like this, right? And so if we do the vertical line test, we find out that part B is not a function. So then the other thing that we might need to do is eliminate the parameter. And so eliminating the parameter means we're given parametric equations, but we want to put it back into a rectangular equation. So we want to get rid of the t. And the way that you eliminate the parameter kind of goes through this process. We're given these two parametric equations right here. So your first step, this is kind of your step one right here, we need to figure out what one of the equations equals in terms of for t, or solve one equation for t. If one of your equations has a t squared and the other one doesn't, then you're probably going to want to solve the other equation for t. So in this case, the y equals 1/2 t is a little bit easier. If you multiply both sides by 2, you get that t equals 2y. So then to eliminate the parameter, we go to the second step here, which is to substitute into that other equation. So if t equals 2y, then in our other equation, we're going to plug in 2y for that t value, which is what they did right here. And then the third step is really that's just your rectangular equation because now we just have x's and y's in the equation. So now you can recognize that the x equals 4y squared minus 4 is a parabola with that horizontal axis and a vertex at 4, right? Because we could rewrite this, if we factored out the 4, we would get the y squared minus 1, right? So we're kind of back in that parabola format with that y squared equation. When converting equations from parametric to rectangular form, you may have to alter the domain so the graph matches the graph of your parametric equations. All right, so let's look at this next example where we are going to eliminate the parameter. Okay, so here, what I'm going to do, remember our first step is to solve one of the equations for t. And because y has a t in the numerator and the denominator, but x only has one of the t's, I'm going to actually solve this x equation for t. So first I'm going to get rid of the square root. So I'm going to square both sides. So I get x squared. 1 squared is 1. The square root of t plus 1 squared is just t plus 1. Right? And again, we want to solve for t. So if you were to multiply both sides by t plus 1, we would get x squared times t plus 1 equals 1. We need to get t by itself, so let's divide both sides by x squared. So we get t plus 1 equals 1 over x squared, which means that t equals 1 over x squared minus 1. So that's kind of that first step, solve for t. Now remember, your second step was to substitute that in to the other equation for all of the t values. So we could say then that y equals 1 over x squared minus 1 over 1 over x squared minus 1 plus 1. And if we work on simplifying that, we get 1 over x squared minus 1 over 1 over x squared. So instead of dividing by 1 over x squared, we could say 1 over x squared minus 1, right? Times, instead of dividing by 1 over x squared, we would be multiplying by x squared over 1. So if you distribute that, you get y equals 1 minus x squared. One thing we do need to consider, and we kind of mentioned it before, is that you may have to set a restriction on your domain. So with this general rectangular equation, normally our domain is all real numbers. But if we go back to the parametric equation, we know that because we have the square root of t plus 1, that domain for the parametric equation, so the domain for the parametric was that t was going to have to be greater than negative 1. So if t has to be greater than negative 1, then what you need to do then is figure out what does that mean in terms of your rectangular equation. So if your t value is greater than negative 1, then that would mean then that your x value, right? So if we were to go back to this t equation where we solve for t, so if the lowest number we could plug in here was something that would get really close to negative 1, we would know then that our x value would have to be greater than 0, right? Because this t has to be greater than negative 1. So our x has to make sure then that we're greater than 0. That's that restriction there. All right, so finding parametric equations for a graph. So we've been looking at techniques for sketching the graph with parametric equations. So now let's reverse it. And how can we find a set of parametric equations for a given graph? So let's look at this part right here. So what happens is if we're given the equation x equals 4t squared minus 4 and y equals t, and we have a parameter, then it produces the same graph as if x equals t squared minus 4 and y equals t over 2. Okay? So it's possible that you can have different parametric equations, but if you have different parametric equations and they produce the same graph, then your t or your parameters are probably different. And with this one, if you were to multiply this parameter by 2, so if we were to multiply negative 1 by 2, and we get negative 2, and if we multiplied 3 halves by 2, we would get 3, right? So then what happens then if we're multiplying this by 2, if we divided by 2, right, and divided by 2, you would end up with those same equations. So let's find a set of parametric equations to represent the graph of y equals 1 minus x squared, first using the parameter in part A that t equals x. So if t equals x, then if we're writing our parametric equation, we would say, well, okay, x is t. And so if x is t, then again, we'll substitute in for the x. So y would equal 1 minus t squared. For part B, if we solved this equation for x, we would get that x equals 1 minus t. So that would be that first part of our parametric equation. If we substituted that in for the x, we would get 1 minus t squared for the y. Or y would equal 1 minus, if we FOILed this out, we'd have 1 minus 2t plus t squared. And if we distributed that negative, you'd have 1 minus 1 plus 2t minus t squared. Okay, so our y equation would just be 2t minus t squared. So if we were writing the parametric equation, our x would be 1 minus t, and our y would be 2t minus t squared. And so then this next slide just shows those two different parametric equations, but they produce the same graph, right? Because again, we didn't start with those same parameters.